Time to take a look at the Uppy Downy bits. Hello everyone, Adam here from CRT. Today we're looking at the Z-axis components of my custom 3D printer. The Z-axis is the vertical axis, in this case a bed that goes up and down. In this video we're just covering mainly the printed components. The actual bed itself and the heating element will be covered in the next video. The Z-axis motion is going to be driven by this. A lead screw. Obviously with a lead screw you need a lead nut, as it were. And to hold the lead nut you need a little bracket. The heated bed is going to be made from 2020 extrusion, as with everywhere else. So the bracket mounts like so with M5 screws, and the nut mounts like so with M3 screws. I think this bracket's probably a little bit flimsy around these holes. This area in here is a little bit funny. There's nothing to hold the nuts in place, so that's not great either. But the rest of it works sort of okay. Version 2 is quite similar to version 1, but a little bit wider. The reason being, this bit allows for more space for the coupler between the lead screw, between the lead screw and the stepper motor, which allows the coupler to come all the way up to this surface instead of hitting and scraping along the extrusion. The third design I moved on to is this. So this one's really bulky. What I wanted to do was move the bed down relative to the lowest plates that the nut could reach. With the original design, if we imagine the nut being in the same place, the extrusion would have to be much higher, and thus the bed much higher, which would reduce the Z-axis. Again mounted by M5 screws, with some captive nuts in the bottom, and a cutout here for the coupler. The problem with this is as the bed gets close to here, then this plastic is very close to the bed, and if I'm printing something at 80, 90, 100 degree bed temperatures, I think this PLA Plus or even PETG is going to see some significant softness at that temperature. Next we've got the Z-axis stepper motor mount. This is very simple. Goes on like that. Screws, screws, and then stepper mounts here. Like so. It's nice and rigid, but to be honest, probably a bit too rigid. This face here does actually limit the Z-axis build volume. So as this comes down and it contacts this face, we can get a couple more millimeters just by trimming off this extra piece of plastic. These two mounting holes really aren't needed. The final version will be cut off just with 2 holes, I think. So that's the driven component sorted. What makes it actually go up and down, but we've got to keep it straight and level. So for that, we'll use some steel bar. The first design I did was this. It mounts to the 2020 frame like so. Very simple. Screw through the top, screw through the front. Bar goes in here and screw goes in here. This was the early captive screw sort of system I had, where you just use a single wall and the screw would go in whatever side, and the nut can go in either side, and the nut just jams against the edge as you tighten it. It works okay, but I think it's a, I don't know, I don't really like it. It doesn't seem efficient. This little clamp seems a bit flimsy compared to the strength of the rest of the part. So given the improved clamps that I've used in other places, I've adopted that design as I move to this. This mounts in here the same way as normal. That mounts to that. M3 screws going through here to mount to the frame. I'm sort of trying to move everything to M3. So if you've gone through, a lot of the stuff that mounts to the frame is M5. I'm hopefully in the last final design going to have everything as M3, because M3s are going to be plenty strong enough for this. There's no need for M5 screw. And I think M3 uses a little less space and looks a little nicer. So this clamp is going to hold this bar with a captive nut in the back, and that will hold it about halfway down the length of that bar, which for my design will give you this same offset at both ends. So the same at the bottom, and it will then look like that at the top. Now we've got this mounted, we've got to have something to ride up and down it. We'll need a bearing. The first thing I looked at was the classic LM8 UUs. So this is the first design that I looked at. Essentially works by mounting this part to the frame. Then you sit the bearing in here, and then you clamp this over the top. The bearing can't slide out because of the extra faces in here. And that all generally works quite nicely. So I sort of went along with that design and improved it slightly by just slightly changing the geometry of this part, moving to the standard captive nut style that I've used elsewhere, and just sort of simplifying it a little bit. So having got this far, I wanted to have a look at some other bearing types because it's quite difficult to see, but this bearing does in fact have quite a little wobble, quite a lot of wobble. So while using this clamp, I made one of these, and that houses one of these. This is a sintered bearing, which is a bit more expensive than the element you use, but I thought that they were going to be better because they have a tighter fit to this. They don't have bearings in them and they're self-lubricating and all that nice thing. So that just fits in there like that. And now that is the same size as this. So this fits in here, that fits on there, and we're happy days. And that fits in there quite nicely. Well, I say quite nicely. What? Come on. There we go. So it fits pretty well, really. The problem with these bearings is as soon as you apply torque, so if I'm pushing now, it just doesn't move. So there you go. It just sort of scrapes if it moves at all, it scrapes down the bar. And so when there's 4 of them and they're not perfectly aligned, it's just, the Z-axis was not going anywhere. It just didn't work. So these bearings are a bit of a write-off, really. So I wanted to try and omit some of this wobbling that I got, because when you put this on here, it has a little bit of, can you hear that? That's movement up and down. And that's just, it rocks slightly. So what I tried to do was use the LMA LUU, a longer version of this bearing, and that would eliminate the wobble even at the same tolerance because of its longer length. So I've got this longer bracket that mounts, again, another similar way, and the bearings push in the end. Now, there is still a bit of wobble, but I don't think it's going to be an issue while printing. While you can shake it with your hand, going up and down, it doesn't wobble at all. So unless the head's rubbing across the bed, which, I mean, at that point, your print's pretty much done for anyway, I don't think it'll be a problem. So that's what we got with that. Lastly, for the Z-axis, we'll mount their bed. So this is what I've got to mount the bed. Very simple. Presses in like that, screws in here, and M3 screw with a spring and all that sort of stuff on top. Come back here and a stack, and the bed will sit along there. There'll be 4 of these, one in each corner. One thing I do want to try is these cast aluminium 2020 assembly brackets. They normally mount in the frame like that, and then you have your next bit of frame and you screw them in and put the frame together. But I'm going to file these 2 little things off, mount it that way, and then that will provide the same sort of hole that this does for mounting the bed. It is slightly oversized, so I might put some a plastic part in there to fill that hole for M3. But the advantage is this will not warp with the heat, whereas this will. So I think that might be worth trying. And that's pretty much it for the Z-axis components. In the next episode, we're going to be looking at some miscellaneous electronics and bits and bobs that I've not covered in the previous videos, like the bed itself, stepper motors, sensors, that sort of thing. If you want to watch another video from me, check out the links at the end of the video. Subscribe and enable notifications, and then that's it. Thanks very much for watching. This has been CRT.